Hello friends, welcome to the channel. Today we are gonna learn about ownership in Rust. So let's start with creating a file in the binary folder. So that will be ownership dot rs, and then function main, and then just start. So what is this ownership? Ownership means owning some data in the program, in Rust program. So this ownership is the unique concept in Rust, which has been introduced in Rust, and is not there in any other programming languages like Java, Python, C++. So it is quite a bit, we can say, difficult to grasp it early, but it's easy. So let's take a value. So let x equals to 5, let's say. So now when we are doing like y equals 5, y equals x. So we are what, we have this x variable, and we are creating a y variable which takes the x. So what is happening here? Let's just print it, and then we'll see what is happening here. So x equals this, comma y equals this, and okay, x comma y. So now if we print it, cargo run hyphen hyphen bin and ownership. Okay, now if you see the output, it would print both. So what is happening here is this 5 is what, we can say it is an integer type. So integer is what, integer is a primitive data type. Primitive data types are the data types uh, which are, we can say, not a type of reference. Like structure is a structure takes a lot of space, we can say a contiguous space. So a block of memory is assigned to a struct, to a object, we can say. So where there we have a reference, there we have a concept of reference. What is the reference? Reference is just a pointer to that memory location. So the here, these both are integer types, and for integer types what is happening here is, this is the original value, and here the a new variable y is created, and the 5 is inserted to it. So it's like copying. So it's like copying. So it is not taking the, so y is point, y has a, y is pointing, y is also a pointer, we can say, but a pointer to a fixed a block of memory in in the memory, a block in a memory. So y has, x is pointing to a memory location which is storing 5. Y is also pointing to another memory location which is storing the copy of the value, that is the 5. It is also storing 5. But let's say when we have, let's say, let s is equals to I love Rust. Okay, and just take it, make it string. So if we just try to copy it, and let s1 is equals to s. Now if we print ln s and s1, and it would be s comma s1, and let's run it. Okay, what are we getting error? Let's understand the error. So what it is telling us that we created s. So this memory location, this string has a memory location which is given to this s variable. So s is a pointer here. Okay, now we moved the value, that is the s, to s1. So now s1 is pointing to the memory location. So strings strings, objects, these are or array or slices in Rust are different from primitive data types. So in this case, what happens is, like when you do this, it is fine, and when you run this, y is also valid and x is also valid till here. But if we talk about this string is what a not a primitive data type. So what happens is, s is s is pointing to this string in memory location, in memory, and s1 is also pointing to this s. Now s initially, s has was the owner of this string in memory. Now s1 becomes the owner of this s1 becomes the owner of this s. Now s1 here is no more valid. Who? S1. Who? S is not valid here. So this is how. So what can we do is we can just use clone method. So what this will do, it will do the same thing. That is, it will what it will do is, let me take it down. So what it will do, it will create a new memory location and copy this string there. So that is copying the data, and that memory location pointer is given to s1. So now s1 has a different memory location, s has the different memory location. But without clone, what is happening? If we don't have a clone, dot clone, then memory location is pointed by s here. Now that pointer becomes s1, and s is no more valid. So that's why we were getting error. Now uh, now there are other concepts also, which are like this clone method. So clone method is used very much in the concept of ownership. And then we have let's say we have this let's say create a function. So a function takes underscore ownership, and let's say string we have, and we are just printing here uh, s equals comma s. Okay, and let's take another function, does not take ownership, and now we are printing uh, n, which is of type i32, that is integer of 32 bytes, 32 bits, I think, 32 bits. So println, and that's just we are printing what this n is. So n, and let's say, so we can see this thing here also. What we can just pass. So let's say let's say we first do it this, does not take ownership, and we are passing our x value there. Okay, and passing that x value there, and then we can do println x equals x. Okay, now we are going to call this takes ownership. So we are passing the s string, and now we print. So this is where you will understand this concept more deeply. So what did we do? We created two functions which takes a string and just it is printing. Another function which does not means that with the name does not take ownership, which has i32 as a argument, and we are just printing there. So what I'm trying to explain is that when we pass x is what of primitive type, and then we run it, what will we get? Obviously it should not give any error. But here, because we are passing a string, so this ownership has been passed to this function. So this is also concept. When you call a function, so that function takes the ownership of that variable. So now s has been s ownership, as the memory location that s was pointing to has been moved, its ownership has been moved to this takes ownership function. Now if we print that s after this, it should give an error that it is not valid here. Let's try to run it. Okay, yes, we got the error. It's take it says that in the function this parameter takes ownership of the value, and after that we are, or what are we doing? After this we are printing it. So it is saying valid borrowed here after. So this is what it is. So thanks for watching. This is our ownership concept in Rust.